Okay, so if I remember correctly, we kind of have our board working now. We were just starting the who's a winner thing, right? All right, so let's run this real quick. All right, so right now we're dealing with our board in terms of putting in a row column, right? Actually, not row column, just a number. It's 0, 1, 2, 3, 4. So 0 should be upper left. Yep, and then 1 is the guy next to that. And we have it alternating back and forth, that kind of stuff. Okay, so now we need to be able to check for a winner on the board. So we started writing this function last time. Let's see, how do we kill this? Here? There we go. All right, so what makes it a winner? So we could have a winner if this guy, and this guy are all the same color. If this guy, and this guy are all the same color, I think we also, when we make moves, we set who moved. Oh no, this takes in who moved, and then we're well, no, each individual Monkey King knows who moved him, right? So we can ask a Monkey King who moved you, or we can also look at the colors. So we know that there's a winner if the colors are all the same. And then we can ask who moved you to find out. But we don't even need to ask that if we're checking for a winner after each and every move. If we're checking after each and every move and we find a winner, the guy who won is the one who just moved, right? So we don't even need to ask the Monkey King who moved you once we determine if there's a winner. So really what we need to know is, are all these guys the same color? Are all these guys the same color? Are all these guys the same color? And then the horizontals. Okay, so how do we ask if they're all the same color? Well, we have two different colors, so let's go back to check for winner. Okay, this is what we were starting. So this is a winner for row 1. And what we can maybe do this is we can maybe break this down into a couple of different variables. I'm actually going to start a new variable here. Let's call this red winner R1. We'll be verbose about this. That way we don't have these crazy looking booleans that makes it impossible to pull off with Alice. All right, so this is going to be a boolean. And we'll start it off as false for right now. All right, so we want to ask the question if the first element, we're dealing with row 1, so if bucket 0, bucket 1, and bucket 2 are all red. That's what red winner for row 1 means, right? If every single one of them is red, that means that red won that row. All right, so these are going to be ands. And we'll just start them off as trues for right now. Then we'll replace that second one with an and. True, true. Okay, so if these three things are all true, and we're dealing with a Monkey King at bucket 0, so that is, how do we get that guy? Is it a property of our scene? Who has my, oh, these are the individual guys. We have them in an array though, don't we? Oh, we had them in an array. Every Monkey King. No, we have a Monkey King array that's owned by, oh, it's a just in play tic-tac-toe? Oh, the board. Yeah, thank you. So we should be able to say, so where's my board here then? Do we have to give ourselves a local variable for the board? So it seems like I should be able to set, well actually we need to do a math function there, that's probably it. So we want to find out if, I assume the colors are probably numbers. Alright, just the board length. So let's see if we can switch this to be, there are two things. Oh, come on. We might not be using this just out of incapacity to actually do it. Nailed it. All right, so do we have access to, can we get the color of an individual monkey? We need to put him in a variable and ask him to give us his we can get Monkey King 1 and then we can get paint. So that might be the way we have to do it here. That's for joints. And who moved me is what, a number? When we make a move, we're taking in a player num who moved me. Okay, so it looks like we can't compare colors, so we'll have to just compare the numbers. So this is, let me switch this back to equal on whole numbers. So if the first monkey who moved me is equal to the second monkey who moved me, and the first monkey who moved me is that phrasing? Did who moved me? Oh, I need to change that second one to a mathematic whole number dealy. Is equal to the third monkey who moved me. All right, and this actually will be the whole winner for that row. So we'll delete this. Am I not able to rename that guy? Well, we might just have to pretend like that's the... We can't rename a variable? That can't be right.
Try clicking out of it. I think it could still select you. So like click on your space.
I mean, like, when I hover over it, it changes. Oh. Whoa, that was like, it had to be really precise. Or like not precise at all. Then I can't believe I didn't actually try to right click on it before. Alright, there. I'm going to lowercase w just for naming convention. Typically variables start with a lowercase letter. Just naming convention. Okay, so that is winner row 1. And what happens here if I drag this down? Can I rename this guy to row 2? Oh, good. I think that should work. And this is 4 is equal to 5. And 4 is equal to 6. And copy. And this will be winner row 3. Seven is equal to 8. 8 is equal to 9. And then winner diagonal 1. So that's 1 is equal to 5. And 1 is equal to 9. And then the other diagonal. D2. 3 is equal to 5. 3 is equal to 7. All right, so that's my diagonals, and then we're ultimately going to return if any of these are true, right? All right, so we're going to throw our return statement up here, and whatever we're returning, we'll just put in true for right now. And we're going to return some ors. So we have 1, 2, 3, 4, 5. So this or this or this or this or this or this, 2, 3, and one last one, this or this. This is winner R1 or winner R2 or winner R3 or winner D1 or winner D2. All right, so that should be check for winner. All right, so let's go back to play tic-tac-toe. Play tic-tac-toe currently has the Mad Hatter setting up the board. Of course, he pointed out last time the Mad Hater. All right, so Mad Hatter sets up the board. Then we'll go ahead and get our user in. Well, get a number for our user input. number for our player mover. So actually, now that I know how to rename these, I can rename this player move. And oh, it didn't fix it in all the other places. That'll be interesting. Go ahead.
We still have to do vertical.
We do. Yeah, we do. Well, here, let me go back and fix this now that otherwise I'm going to forget, because I just changed this to player. We'll just leave it as player mover, I guess. So what does this guy do right now? He goes through. So for as long as we can keep going right now, we're just going to let him play. We'll get the user input. We'll try to make the move. If the move was a successful move, we'll toggle between our two players. But before we do that, we should probably check for a winner. So upon a successful move, if we'll call check for winner, passing it the current board. If that's true, then we want our Mad Hatter to claim who won. All right, so we will say, for right now, we'll just have him say, we have a winner. Otherwise, we'll keep playing. So we only have to toggle if we didn't have a winner yet. And right now, we're not getting out of this loop. So we need to keep going. We'll probably change our while loop here in a few minutes. All right, but right now, we'll just allow them to keep trying to play, but as soon as there's a winner, we're not going to let them, I guess we're not going to let them make any more moves. This will at least now announce a winner. So let's go back to check for winner. So we need a couple more of these, we need 3 more of these booleans, right? So we'll copy this. So we're going to get our column 1, column 2, column 3. So this will be C1. C1 is 1, 4, and 7. C2 is 2, 5, 8. That's 2. That's 5. That's 8. And then C3. Actually, I'm getting a little concerned. When you hover over everything and everything lights up. Oh, that's actually interesting. I've been trying to do that for a while. Be able to just drag something from here into another place. So this is going to be called C3. C3 is going to be 3, 6, and 9. Okay, so working theory is we should be accurately checking for a winner now. All right, so we'll make a move at 1. We'll make, oh, that, oh. We actually mentioned this last time that we'd have this problem. Because we start off our who made the move at a -1, I think. Right now we have a winner after the first time because there's 3 -1s in a row, right? Both vertical and horizontal. So we really need to have a legal move. So each of these guys need to get even scarier, because now we're saying, are they equal? And also, is it not equal to -1? So what we probably could do here is we can throw an if statement. That might be the fastest way of doing it. Let's assign to winner 1. I'm going to do an and. And we're going to whole number not equal to, should we just say 0 and -1? What whole number? So we'll overwrite winner R1 with the and of who moved me not equal to -1 and whatever winner R1 already was. So if it already was a true, and the guy who moved R1 is not equal to -1, that means it was a real player. If both of those are true, then it's actually a winner. But if the guy who moved MK1 is a -1, which means nobody's actually moved him, that would be a false. False and true, even if winner R1 was a true, is going to ultimately be a false. Okay, so this allows us to filter out a false positive by doing an and on whether or not a real person moved the first thing. So now we should be able to do that for each other one. We'll do that for winner R2. Looks like we can just do. Are you kidding me? I could copy everything but what I want to copy? Let's try this. So we're going to say winner R2 is equal to can we drag it? Can't drag it. All right. So we just have to. Hey. So that's -1. And this is going to be Monkey King 4, who moved me. And R2. All right, so that's for winner R2. I guess this isn't so bad. Winner R3 is going to be an and. Say true and true. And then the first part is going to be a not equal to something and -1. What's that something? It's going to be Monkey King 7, not equal to -1, and winner R3. Then winner C1 is equal to an and. True, true. This first one is a whole number not equal. 0 and -1. This guy is going to be monkey king 1, get who moved me. And winner C1. Then we'll have winner C2. True. This is going to be an and. This is going to be not equal to. -1. And this is going to be MK2, get who moved me. There. And winner C2. And a winner C3. Assign. This is going to be an and. True, true. This is going to be a not equal to. -1. And this is for column 3. So that's going to be MK3. Or you could use MK6 or MK9. Then D1. And this is going to be an and. This is going to be a and that's going to be that guy's the first diagonal. Get who moved me. Right there. And D1. And then finally, D2. True. This is going to be an and. This is going to be a whole number not equal to -1. This will be that guy, MK3, get who moved me. That's winner D2. All right, so that should filter out false negatives, or false positives rather. So make a, all right, and then we'll do 1 all the way across the top. So, so we need to do a 4. Oh, okay, that's whatever. 2, then a 3, and then a 1. And we should have a winner. Yeah, we have a winner. Okay, and then we could, well, those are going to keep cooking here. All right, so it seems to be able to detect a winner at least on 1 horizontal. Right now, we should probably test it a little bit more exhaustively. But in any case, we'd like the game to probably stop when there's a winner, right? So we need to modify our while loop to no longer keep playing when there's a winner, and then make some announcement of who actually won. We actually probably don't need to make the announcement of who won. We just want to stop asking. Okay. So right now, our while loop just says keep going forever. Really, we want to keep going as long as there actually hasn't been a winner, right? So what we can do is we can create a variable right before this. And we call this guy isWinner. He's going to be a Boolean. And we set that equal to false initially. So initially we have no winner. So now we can say while not isWinner. So while there is not a winner, keep going. That is, if isWinner is currently false, not false is true, it's going to keep going through. Because as long as this Boolean expression boils down to true, we'll keep asking the same question over and over and over again. Or keep doing the body of this loop over and over and over again. Where we get our user input, we try to make the move. As long as we had a move success because we checked for illegal moves last time, then we go through here, we check for the winner. If we have a winner, we say we have a winner. Otherwise, we move on to the next person's turn. We ask them, so on and so forth. As soon as there's actually a winner, we've announced that there's a winner. Now we can go back here to our first method where we're playing tic-tac-toe. All right, so whoop. Siri listens in sometimes. It seems very strange. Let's see. Well, at the very least right now we'll stop playing. So let's do that and then we'll allow us to repeat. So let me set up the board. So we'll do 0, 3. And we'll test a diagonal. So that's going to be 0, 1, 2, 3, 4. And then 8. We have a winner on our diagonal. Okay. Oh, we never actually. So we're looping on whether or not we have a winner on isWinner. But we never actually set isWinner down here if we had a winner. So we need to go ahead and assign, if we have a winner, we'll set isWinner to true. Now it should actually exit. So let's do our other, let's do a vertical now. So we'll go 0, 1, 3, 2, 6, 3, 4, 5, yeah. Oh, it did not get column 1 winner. Let's see. Check for winner. Column 1 says the first, oh, this guy. First guy is equal to 1, 2, 3. So 4, if he's equal to 4. And, oh. MK1 is equal to MK7. That looked pretty butchered. MK1 is equal to MK4. That's first two. Then MK1 is equal to MK7, the bottom one. Let's see, 1. C2 says MK2 is equal to MK5 and MK2 is equal to MK8. And this is MK3 is equal to MK6 and MK. It seems like I just got flip-flopped here. Never actually changed the second one. And then MK 3 is also equal to MK9. Those look good. That looks good. All right, so let's test our first column again. So it's a 0, that's a 1, that's a 3, that's a 2, and that's a 6. 1 is equal to 3. Well, actually, it would be 0 is equal to 2. Yeah, 1 is equal to 4. So that's the two guys right on top of each other. And then 1 is equal to 5, 6, 7. So this is MK1 is equal to MK4, and MK1 is equal to MK7. And winner C1 checks to see if MK1, who moved me, is not equal to -1, and winner C1. Oh, anybody see where the problem is? It's my fault, then it's his fault. But I did it on purpose. So you asked, don't we need to check for
You didn't put it in the return statement.
yeah. So we do all sorts of fancy question stuff here with column 1, column 2, column 3, and never actually take it into consideration when determining if there's a winner down here. We just did our 3 rows and our 2 diagonals. We need to go and add those to our columns, right?
Is that my fault?
Huh?
Is that my
Well, you were halfway to the answer. You didn't correct me. I was doing that to test you.
I got you now, though.
Ay, ay, ay. Okay, so let's go ahead and let's do our column winners. So here's a row 1, row 2, row 3. And let's expand this to be row 3 or column 1, and we'll expand column 1 to be column 1 or column 2, and we'll expand column 2 to be column 2 or column 3. And then we have our or. Winner 1 or winner 2 or. Actually, it looks like we could have written this cleaner. I'm going to do something here. I'm just going to rewrite this thing because I think when we originally picked it, we did a bunch of those blank or blank things, and I think that was correct. It just looks funky. So if we now fix it to do what we were just doing, we'll say winner row 1, but we're going to change this to winner row 1 or row 2, and we'll pick winner row 2 or row 3, and row 3 or column 1 and column 1 or column 2, column 2 or column 3, column 3 or diagonal 1, diagonal 1 or diagonal 2. Uh-oh. Either. Either. So 1, 2. C1, C2, C3. Okay, so we're missing row 3. So this one needs to be expanded to be either C1 or R3. And then we can probably just flip-flop these guys. Row 1 or row 2 or... Tried to be so careful, but I threw an and in there. Again, this still works, but it's ugly right here. We have 2 eithers in a row. We fix it again. R1, either R1 or R2. All right, so make sure I don't pick and for anything. Either R2 or R3. Either R3 or C1. Either C1 or C2. Either C2 or C3. Either C3 or D1. Either D1 or D2. R1 or R2 or R3 or C1 or C2 or C3 or D1 or D2. All right, that looks correct. I think all of those would have worked. These just, instead of having like it broken into multiple ethers inside of an ether inside of an ether, this will flow smoother. So now let's run it. We should be able to get a column 1 winner. 0, 1, 3, 2, 6. We have a winner. There we go. Okay, and he stopped. Okay, so finally, we probably want our Mad Hatter to ask us if we want to play again. So we automatically play once. He'll ask us, do you want to play again? So we'll close that. Let's go back to our first method. So after we play tic-tac-toe once by default, we're going to have the Mad Hatter ask a question. do you want to play again? And we'll go ahead and read in from the user. So we'll get a string from the user, yes or no. Good enough. We need to put that in a variable though. Answer is going to be a text string. And we'll start it off as actually, it doesn't matter because we're going to be filling it in with something else here in a second. So we'll replace that hello with get string from user. Oh, and I forgot, we can actually, we prompt them through that, right? So we'll do custom, you want to play again, which means we don't have to say it up here. Okay, so we're asking them if they want to play again. We'll say yes or no. We'll ask the if statement if text string comparison content equals answer and yes, all lowercase, then we want to play again. Otherwise, we don't want to play again. And we'd like this to work forever. Ask us over and over and over and over and over again. So for our homework assignment, update, take it the next step. You can do this in as few as one line of code. As little as one line of code. So for our homework assignment, have the guy ask, we'll play once, then we'll ask, do you want to play again? And if we play again, have him play tic-tac-toe again. After that game, do you want to play again? Play again. So on and so forth until he finally says no. So if he says no, then we can go ahead and have the Mad Hatter finally say goodbye or something like that. See you. That's when he's done. Okay? But when he answers yes, they need to play again forever. Make sense? All right, so that's the homework assignment. I'll put up a screenshot of, well, actually, it's not going to work anyways. I'll try to zip up this project and submit the project along with this. But I would encourage you to practice with the Alice way of doing things, but I'll try to give you a starting point for this.